Okay, so what is the first package we always need? Tidyverse. And what do you do? Library, Tidyverse. You don't have to install it again. All you have to do is load it. Yeah, you can put that in double quotes. It also works without double quotes. That's okay. We learned double quotes, I think. Okay, and make a note for Tidyverse, for network analysis, we need one more package, which is called iGraph. So we need one more package. We have to first install it. It'll be called iGraph. Look on the screen, iGraph. And once you run it, you have to load it. Any questions so far? So just make a note, network analysis, we need additional package, iGraph. All right, first let's do the basics of network analysis, just small example. Okay, so for example, say you have the all right, so let's say you have the first person in your community following the second person. Then say the second person in your community follows the third person, then third, the fourth, and so on. So what you do is this data should be turned into a vector. So how do we make this data into a vector? Any ideas from class before? How do you make data into vector? What function do we use? Let's do a small example first, just one following two. What do we do? We use the, anyone? Very good, we use the C function. And we save this in X. One is following two, that's all we know for the basic example. And we run this. We have a X variable, 1, 2. All right, now a new thing, we define a graph. Let's call it G1, or let's call it just G. And we say G should be graph, bracket, X. So we define a new graph, and we save the vector into the graph and call it G. And run this. So if you look on the side here, we have a G object here. But the next thing we want to do is from this graph, we plotted the graph. So the new function to use is plot. This is not ggplot anymore, okay? This is just plot. And you say plot G. Okay, so if you run this, see what happens. Look at that, not good. Look at that, it's made a network diagram that one is following two. saying that 1 is following 2 with the arrow going from 1 to 2. So make a note, these circles will be called as vertices or vertex. So the followers in your network will be the vertex. They will also be called nodes. Write it down, N-O-D-E-S, nodes.
The number?
Yeah. So these were your people in your community. They become vertex or nodes. And the thing connecting them will be called the edge. And if you have an arrow going from one point to the other point, it'll be called a directed graph. If this arrow is missing, we say a non-directed graph, but we won't do that. We'll do the directed graphs. If this arrow is missing, we'll call it the undirected graph if there's only an edge. But if the arrow is there, we'll call it a directed graph, and we will only do directed graphs. So let's increase our community. Let's say 2 follows 3, 3 follows 4, and 5 follows 5, something like this. And run it again. For some reason, it's not showing good here. We'll fix this. Right, does that make sense? 1 is following 2, 2 is following 3, 3 is following 4, and 5 is following itself. Just make a note, when something follows itself, it's called a loop. So this is also an edge, but it's also a loop. It's following itself, around itself. Did you put like that? There should be 2 twice. It shouldn't be 1, 2, 3. Loop, L-O-O-P. L-O-O-P, loop. Yeah. L-O-O-P, loop. Okay, now write down, once you have the network diagram, you have to format it. We'll check when we do it, yeah. Okay, this is how you format your network diagram. You put a comma after G and enter. And you pick a vertex color. So you say vertex dot color equals. Now, for some reason, this only takes American English. It won't take COLOUR. So just COLOR, okay? So just make that note. Tell me a color you want for the vertex. Let's say red. And then you also give vertex dot size. Sorry, question? All right, give a size and so on. Let's run it and see if there's any changes. Look at that. It will look better on your computer because if you have a bigger screen, it looks better. Yeah. 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 Does it make sense what's going on? We change the size of the vertex and we change the color. If you want to change something else, you say edge dot color. If you want to change the color of the edge, what color would you like? Green, okay. There is one more, which is edge dot, let's see, edge dot arrow dot size. You want to change the size of the arrow. It'll become really ugly on my computer, but let's see. Look at that, it's becoming ugly. So it may look better on yours. Right, this is a bit better. Yeah, this is better. Look, for my screen, this size is better. It should look like this. So 1 follows 2, 2 follows 3, 3 follows 4, and 5 follows itself. That's your network diagram for your community. Any questions so far on what's going on? Yeah. It's not working from? You have to first install it and then library. Okay, now make a note. You can do the same thing for names as well. Instead of numbers, what if you have names? If you have names, all you have to do is in your vector, you give the names in double quotes. So A is following B, D is following C, and so on. And your names should be in double quotes. Just make a note. Number doesn't have to be in double quotes, but your name has to be in double quotes in the vector. Let's see, how does this look? Yeah, so look at this. A follows B, B follows C. What does it say? We'll see when we practice. Just take notes for now. Well, any other questions so far? Yeah. Yeah, so A follows B, then B follows C, then you have to put both of them. If you just put C here, C will be alone. Okay, now let's see how to do the same thing with a data file. So far we did it with just vectors. Now we do it with the data file. So the first thing you do is what do? You want to use the data file, df, and what is the command? Very good. So first we have to do is read the file. We say df read.csv What was the name of the file? Even though this is week 10, the file says week 9, okay, because it's from last week. We have the DF here. Okay, so just take a look at your file. This is the data you have of the people in your community. We will make a network diagram of follower and following. So this guy follows this one, this guy follows this one, and so on. And this is all additional information about them. Yeah, we will only make a network diagram of follower and following. Now, what do you understand by this weight here? Any ideas? What do you understand by the weight? Is that the weight of the person? No, so just make a note. The weight in a network diagram is the weight of the edge. It means how much importance you give to that connection. Okay, so the weight means the importance of the connection. If it's 4 in this example, it's of the highest importance. And 1 is of the lowest importance. Yeah, it's the weight of the edge. So it's the weight of the connection. How much weight do you give to that connection? Lowest. And 4 is the highest. Right, now what we want to do is we want to create a new data frame where we only select the follower and following. We cannot make a network diagram with the whole thing, only followers and following. So how do we do that? I want to create a new data frame. Somebody help me here from. Very good. So we call it DF1 and we say DF. And what do? We want to only select followers and following. Or let's see, only select followers and following whose age is bigger than, say, 32 or something. How do we do that? Anyone remembers? How do we make a new data frame where we only select certain people and we filter things out?
Oh, use filter.
Very good. Before that, pipe operator. Very good. We need the pipe operator here. And enter. And we say filter. Say age bigger than or equal to, what did I say? 33. Okay. Another pipe operator, enter. We say select only. Just enter, yeah, right now. Because we're making the code right now. When you want to run it, you do control enter. And then select just the follower, comma, following. So this will create a new data frame that will help you make the network diagram from this. Age not found. A is capital. Yeah. So now look at DF1. It's got only the people who are bigger than 33. Okay, now let's make a network diagram of DF1. Let's see how to do that. Earlier it was just a vector. Now we have df1. So let's call it G2 or G1. This is a new network diagram with a new data frame. Let's call it G1. Okay, the new command here is graph dot data dot frame. Earlier we only needed graph. Here we need graph dot data dot frame because we are working with data frames now. Does that make sense? Earlier was just a vector. And here you put the data frame df1. And run this. So you should have df1 on the right side, and you should have G1 also on the right side. And then the same thing plot G1. No ggplot now, just plot G1 and see what happens. Be ugly, but we can fix it. Look at that. Maybe it looks better on your computer. Check. Yeah, it's better there because you need a bigger screen. Okay, so let's fix this. Let's give a color you want. Vortex.color. Give me a color. Blue. Then vortex.size. To 10. Then edge dot arrow. This will help me look better. So let me do 0.5. All right, vortex size should not have double quotes. Yeah, this is a bit better. Is that okay so far? This is how you make a network diagram from your data frame. It's the same thing, but just a little bit new. We're going to learn some basic commands for networking. Okay, very important. If you do degree of G1, look at this, degree G1, new command. Are we doing G1? Any guesses what will happen if I do degree G1? There's no vector now, we're dealing with the data frame. But what do you understand by the degree? That's the question. So let's see, if I run this, let's see what happens. So look at that. It's not the weight. So very important, write down the degree means for person B, there is only one follower or following. For person C, there is one follower or two followers or following. For D, it's pretty big. So there are around 7 people who are either followers or following. That's the degree of D. So now, for example, if you just want to see who is following whom, you have to do mode equals in. If I do mode equals in and run it, look what happens. So B, nobody's following B. C, nobody's following C. But D, there are 4 people following, and so on. Make sense? And similarly, if I do mode equals out, run it, see what happens. It means B is following 1 person, C is following 2, D is following 3 people, and so on.
So in makes you look for the first variable and
It makes you look for who's following that person. And out will show you who that person is following. Okay, next one. If I say V bracket G1, see what happens. It's telling you how many total vertex you have in your data. It's listing all of your vertex. Similarly, if I say capital E bracket G1, any guesses what will this tell you? V stands for vertex, E stands for edge. It will tell you the total edges in your data set. Vertices, yeah, and E will show you the total edges. And one more important thing, if you do G1 with these 2 brackets, any ideas what will happen from the first or second class if I put these brackets here? If you remember, if anyone remembers. All of them, but what does these brackets represent? Oh, very good, very good. Something more? Columns and rows. So it will convert your data into a matrix. If you remember the matrix part we did. So if I run this, see what happens? Look at that. So wherever there is a 1, it means this person is following that person. This person is following that person. Wherever there is a 0, there is no connections. And then a lot of mathematical stuff can be done on the matrix to convert your network into the way you want. But we won't go that deep. We're just doing the basics. But make a note, the G1 bracket will convert this into, yeah.
so for the matrix, it is really talking about the amount of followers, and then
We're talking about the connection. So wherever there is a 1, there's a connection between this guy and the one on the top. It doesn't say who's following whom. If this guy and this guy has a 1 there, then this guy and this guy have a connection, either followers or following. Okay, one more. If you say E count G1, will give you the total number of edges in your network, just the number. And similarly, V count, G1 will give you the total number of vertex in your network, unique vertices in your network. Yeah.
How is that different from?
We will actually show you all of them. If you run V, it will just show you all of them. But this will just give you the number if you want to do some calculations on it, like divide by it or, you know. Are any questions so far on what's going on? So now let's do a little bit of advanced network, okay? Something a bit more. Only one or two more, that's it. Let's do an advanced network. Okay, so let's say plot G1, comma. We're plotting the same thing, but a little bit advanced now. We'll say vertex dot color equals. Now here's a question. For each vertex, I want a different color, right? I don't want the same color for all the vertex. In that case, the function to use is called rainbow. And if I say rainbow bracket 2, any guesses what will this do? Let's run it and see. It's choosing two colors for all of them randomly. I think the maximum number you can put here is 54 or 52. So let's do 22 because we had the 22 number of vertices. So let's see, hopefully it looks better. Now look at that, different colors. Okay, the next one, vertex dot size. Question? You can ask questions. Right, now vertex dot size, what you want to do is, if a certain vertex has more followers and following, they should have a bigger vertex. If somebody has very few followers and following, they should have a smaller vertex. So what you do is you say vertex dot size equals degree of G1 and multiply it with some number. Let's do 2 and see how it looks. Okay, maybe I can make it a bit bigger. 5 to make it look better. Now look at this. Based on their followers and following, the size is changing. This can give you an idea just by looking at your network. Who is the heavyweight in your network? Does that make sense? And there is another important bit, which is called layout. So you have to do layout equals layout dot, and it will give you all possible layouts. Next to the star on 8, above 8. Star, it says multiplication. Okay, so these are some famous layouts of the networks. So let's do this one and see if it changes, and just remove this bracket there. It doesn't look great for me, but let me. I see that that's better. So this are some important layouts which are inbuilt into the package. So if I change the layout to something else, the bipartite will not work, okay, because there are some important graphs which only works with bipartite. But let's do circle and see how does it look like. Now look at that. Your network is in a circular form. Does that make sense? And what does the layout do? It will lay out your network in the way you select the layout. Any questions so far? Right, one last thing, which will be called communities in your network. It means, is there any strong communities in your network which are more connected to each other? So communities in your network. Okay, for this one, you'll have to select or define a new graph, which is called G2. These are also called clusters, okay? So if you hear the word cluster, it's the same as communities. And you'll have to use this function, cluster underscore edge underscore betweenness. There's a lot you can do with this, okay? We're only doing the basics. Cluster underscore edge underscore betweenness. And give the data frame here, df1 that we made. And run it. No, sorry. So here you have to give the graph, which is G1. Not the data frame, the graph. In here, give the G1, not the data frame. And run it. But I'm just going to remove the layout here to see what does it look like. And then in your plot, before the G1, you have to give the G2. So you define G2, and in your plot, before the G1, you have to give the G2. Run it and see what happens. So now look at this. It's forming communities in your network. It's telling you that this community is a stronger community within your network. That this is another one which is a stronger community, and so on. And then what you can do is just filter out these guys and study them in detail. Why are they a strong community? What can you do to them to get more out of them, and so on. Does that make sense so far? So up till here for network analysis. This is the basics of network analysis. Any question on this one, the last one? All right, that's it then. Go to Blackboard and see if you can do the practice. Do this much first and then the practice. Let's hope it's recorded.